Still on enzyme kinetics, today we should be looking at the transformation of Lineweaver-Burks equation to Wolfram's equation for enzyme catalyzed reactions. So this is a continuation from our previous class on enzyme kinetics and conversion of MME to LBE. So how do you convert Lineweaver-Burks equation to Wolfram's equation? Just a simple step. Multiply both sides of Lineweaver-Burks equation by substrate concentration. So this is Lineweaver-Burks equation. Multiply this by S, multiply this by S, substrate concentration, and this. So we have it here. This takes the numerator and becomes this. Substrate concentration cancels, so we have Km over Vmax left here, and then S takes the numerator for this. So this becomes the new equation. And then you rearrange so that we have 1 over Vmax. This comes here and this comes here to show what we plot against what on the graph. So we have K, this is 1 over Vmax times substrate concentration. Why did we change it from this to this? To show you what to plot on the x-axis and what to plot on the y-axis. And so this becomes the Wolfram's equation. So simply, to convert Lineweaver-Burks equation to the Wolfram's equation, all you need to do is multiply through LBE by substrate concentration. So on the graph, you plot substrate concentration over initial velocity on the y-axis, and you have substrate concentration on the left axis. And then, as usual, looking at the graph, you look from the equation, you should tell what will be the intercept on the y-axis and what will be the slope. So that this which is attached to this is the slope, 1 over Vmax. Then whatever is remaining here after the plus or minus sign should be the intercept on y-axis. Now, as we can see, Wolfram's plot is also a linear plot, a straight line graph like Lineweaver-Burks equation. So why bother to get this after this? Now we need to know that Lineweaver-Burks equation has limitations, and basically its limitations because of is a double reciprocal curve where the x-axis is 1 over substrate concentration. The fact that the x-axis on Lineweaver-Burks is a reciprocal means that the graph tends to compress values at high substrate concentration, concentrating values on the 1 over the y-axis at high substrate concentration. But it also has benefits, one of them being that it helps us to explain enzyme inhibition, the various types, and also the fact that it makes it easier to obtain Km and maximum velocity directly from its graph. I believe that we've enjoyed this simple explanation. I hope to see you like what we do here. Comment, drop your questions, concerns and suggestions, share what we do here with others, and kindly follow us on YouTube for more tutorials on biochemistry. Until I see you again, it's Dr. Juliet. Bye-bye for now.